Hello and welcome to The Rabbit Hole, the Definitive Developers Podcast, live from the Boogie Down Bronx. I'm your host, Michael Nunez, our co-host today.
Dave Anderson.
And today, we're still having solid thoughts. We're talking about the open-closed principle.
It's part 2.
It's part 2 of 5. As you can imagine, there are 5 letters in solid, and we'll go through each one of them.
Oh, yeah, by most spellings.
By most spellings, yeah. I mean, don't ask me. I mean, I'm not sure. But yes, it's 5 letters. Today we're talking about the open-close principle, and we'll just talk about examples of the principle, how you can kind of look at a piece of code base to understand whether you're following this principle or not, and examples about what to do.
Finally, explain to your friends over a beer what the open-close principle actually is. I feel like it's so mysterious. Is it open or is it closed?
Well, we're going to get into that right now.
No, you gotta tell me.
Well, it's open and you're able to open it, but then you have to be able to close it. The idea comes from the engineer named Bertrand Meyer, who has written a book in 1988 called Object-Oriented Software Construction. And it states software entities, in parentheses, classes, modules, functions, etc., should be open for extension, but closed for modification. The idea being that you want to make sure that the piece of code that you're writing is easily extendable for the next engineer who wants to add more features to the code base, but not completely modifying it where it doesn't look like the method you first wrote when you first got to this code base.
Right. That's like, OG software engineering book, 1988.
Oh, yeah. I mean, there's probably a lot of C++ talk in there and pointers and all sorts of craziness.
Small talk, maybe.
Oh, yeah. But the idea of like object-oriented programming will exist regardless of the programming language you use. And I have an example. I think we used examples previously, the shapes example, and we can dive into that. I have a real life example that we're dealing with right now at Stride, and I can talk about that as well.
Okay, so we have this haiku from 1988. It's open for extension, but closed for modification. So that means that I can extend the functionality of the code, but I don't want to change anything about it. So I can reduce maybe the amount of bugs that I might introduce into the system. I don't have to tear it all apart in order to add some more functionality.
That is correct, Dave. Podcast over. We are done. Boom. There goes open close. That's it.
Okay. I still don't feel like I'm there yet. So why don't we?
I'll dive in with the example we've used before. So, think about last week and then play the violin. You have a area calculator. Someone, suppose Bobby, is a product owner and wants a area calculator that when you give it a rectangle with 2 sides and you ask for the area, it gives you the area of a rectangle. And the area of a rectangle is the width times the length.
Classic.
And boom, classic. And if you have many different rectangles in a list, if you give it a list of rectangles, it'll give you the area of all the rectangles. So yay, Bobby's happy with this particular piece of code. Bobby now comes up to you and says, hey, we have an area calculator and we got a new shape we have to get the area for, which is the circle. So we're going to use the circle now. One could extend the area calculator so that every time it looks for each, item in the array, whatever shape it is, we have to check if the shape is a rectangle or if the shape is a circle. And if shape is rectangle, then do your area, width times height.
Right.
And if it's a circle, then you're going to do the radius square times pi.
Yeah, I feel like I've seen code like this before where there's a switch case and it's okay, if shape.type is this, then you go into this case and this other case and this other case.
Right. That's one way to do it. But the thing is that we're now modifying this area calculator to handle all these different types of shape. That makes sense.
Right. We want to be done with that. We never want to write an area calculator again in our lives.
In our lives, exactly. So what you could do is the idea of like the open close principle is that you have an abstract class, for example, that has, and we call that a shape, right? And that particular abstract class will have one method and it'll be the area. And any of the classes that we create that uses this shape abstract class will have to identify or like implement the area for that particular shape. So when you create a rectangle, you're going to use a shape, and the area of a rectangle is width times height. Same thing goes for circle, where you get the radius square, multiply that by pi.
Favorite number.
31415 9265 3589 I think. I don't know. Well, someone's going to have to check me on that.
I can't even remember like my phone number, so it's
oh gosh, I can't laugh. It hurts. So the idea is that in your area calculator, all you have to do is for each shape, you can just call the area method, and your shape will have its own implementation on how to print out the area of that shape.
Right. And I guess like, if you don't want to use inheritance, because like all the cool kids are doing composition these days, and you can use an interface or a duct tape too, as long as you're passing in a list of shape that has the area capability, then you can do that.
Yeah, if like just make sure that the method responds to area as a method, and then you should be able to get the area of any shape that you pass in. So the idea is like, if, Bobby comes out of nowhere and is like, hey, we need the area of a triangle, then you could just create a new shape that takes the triangle as an area and then be able to calculate that. And then you never have to worry about extending the area calculator for areas anymore, right? And then you could do like a football field. You can do all sorts of these different shapes if you really wanted to, and not have to extend the area calculator anymore.
Right. Or even like a football.
Or if you want to get the area of a football, you can.
I'm pretty sure there's got to be a equation for that, but I do not know what it is.
I can't even throw a football. I'm so bad at it.
But yeah, like that would be something that'd be like so complicated, like if you just kept on putting that into the area list calculator, and you can imagine the tests would get very complicated as well.
Exactly. And then like rather than testing the area calculator for every single shape, you can just, test each shape that it returns the correct answer when you call area to it. And then it's very isolated from the implementation of the area calculator, and like you can keep the area calculator closed the whole time as you're extending the application by creating these new shapes that respond to the area method.
That totally makes sense. And I guess like on the other side, like when maybe it goes wrong, you can wonder if there's a lack of open closed adherence. Like if you're making changes to a lot of different existing things, like shotgun surgery, then that could be counterindication that like you've not separated things out in a way that let you just like create new code.
Right. So you definitely want to avoid the shotgun surgery. Don't ever get shotgun surgery, and don't do it. If you know that you have to constantly change this one particular class to behave in a way that you want it to, then maybe what you're doing is modifying that piece of code, and think about what you would need to do to make it so you don't have to modify it and just be able to extend it a little bit more. I think we've all seen examples, Dave, as you mentioned, where like this just like a trailing if statement, and then you do the next one, there's another if statement, you do the next one, there's another if statement, and then think like how can you abstract that so that you can leave that class alone and then have the method, the objects itself take care of the area of a shape, for example.
Totally.
So another example that I can use is probably much more bigger than shapes. Straya has an application called the intranet, and one of the things that we need to do as a consultancy is to figure out when are people going to be available so that they can go on to the next client. So we created this page, and it's called the availability page, where we can see the user, we can see what client they're currently on, and we can see their next available date. which is very good because then we can kind of see like, oh, if we see that Susie's going to roll off in 3 weeks, then maybe we could place Susie and Bobby Core, for example, just throwing names out there. And one of the other features that were required for this is to see any future placements that a consultant may have. So, people can be up for grabs to go to different places and different engagements, for example. And, one of the things that you want to think about is if we're going to print out the future placements of a user, we don't want to write that code in the availability page, like right in the JavaScript. What we could do is just have a method in our getters file that can get the list of future placements given a user ID. That way we can definitely extract that information without having all the logic exist in the availability page. We have that calculation happen elsewhere where we can then just fetch that information and then display it to the user. And we can isolate the tests a little differently because then we could just test the getter file to ensure, hey, given this ID, I expect these multiple placements, versus testing that through the availability page will be a little bit more difficult and just like really, really troublesome. So just like extracting all of that out so that it does exist only in the getters file makes it so that it's easier to test, and then we can use it and then be able to display the future placements of consultants.
Right. So like the way that availability is calculated is closed to that page, the availability page, because it just asks the interface for the thing that it cares about, and then it gets it back. So it's like, okay, you do what you got to do to get me this thing.
Right, like the availability page is extensible in that it can add this new column that says future placements, but it doesn't have those calculations in the page. That's somewhere else that's going to fetch that information and then get it and then do things. Gio's very excited about this. Very, very excited about this. At last.
Features.
Yes. Oh, yeah. He'll listen to the 5 episodes and then be a pro and then start making money around here. That's what he needs to do.
He's got to make rent.
Yeah, he's got to pay something. The idea is that the availability page is extensible and that you can add a new column, but we're not modifying it in that, hey, the availability page is also responsible of calculating the future placements. We have that done elsewhere, which is like, you may hear that like a lot of the principles that we're going to spell out in Solid depends on other ones. Like that's going to be a thing that's going to happen. And I think that the open close is definitely very, very strict to the single responsibility. And you make sure that when you're following one, you're definitely going to be following the others as well.
Yeah, that makes sense. Some foreshadowing.
Yeah, as we go through the series, love to hear any examples that we may come up. I'm sure I'm going to run into a lot in the next couple letters that we'll be working through.
So many letters.
Yeah, we got lid. Just the lid. Just put a lid on it. We'll put a lid on it in the next 3 episodes, and we'll see you then.
Follow us now on Twitter at Radio Free Rabbit so we can keep the conversation going. Like what you hear? Give us a 5-star review and help developers just like you find their way into the rabbit hole. And never miss an episode. Subscribe now however you listen to your favorite podcast. On behalf of our producer extraordinaire, William Jeffries, and my amazing co-host, Dave Anderson, and me, your host, Michael Nunez, thanks for listening to The Rabbit Hole.